Okay, Screencast 2, MRP is the demand curve for a resource. Here we go. So we're going to look at MRP again, and we went over that in the last screencast. And we're going to look at it in two different contexts. In the first context, we're going to look at what MRP looks like for a firm that's perfectly competitive. In other words, a firm that's selling in a perfectly competitive product market, something like agriculture or the stock market, something like that. And then we're going to look at what it looks like for a firm that's selling in an imperfectly competitive product market. And the main concept here to try to get your head around is how MRP is going to look different between the two. So we're going to start off with a little table, and you might want to pause the video a couple times to make sure you're keeping track of what's going on here. And along the way, I'm going to start plotting out MRP numbers in a little graph on the bottom of the screen. All right, so starting with 0 units of a resource, so 0 workers. Excuse me, 0 workers would make no stuff. Assuming that I'm selling my product in a perfectly competitive product market for, let's say, a price of $2, total revenue would be nothing. I haven't made anything yet. I hire my first worker. The first worker makes 7 stuff, marginal product of 7. If you take the marginal product of 7 and multiply it by the price of the product of $2, you can get MRP, which is $14. That first worker added $14 to my cash register because he added 7 things and I sold each thing for $2. So that's $14 more stuff than I had before. That's MRP, and I'm going to plot that MRP number of $14 at 1 worker. Okay, let's say I hire 2 workers instead, and together they make 13 units. The marginal product of that second worker would be 6 units. He or she added 6 to the production. If I multiply those 6 units, again by $2, excuse me, what that means is that second worker added $12 to my cash register. So again, I'm going to plot that MRP number of 12 at 2 workers, 12. Now notice here that price isn't changing. And that's how I know we're dealing with a perfectly competitive product market. Remember, in perfectly competitive product markets, price never changes. So I hire a third worker. Let's say that 3 workers together make a total of 18 things, which means the marginal product of that third worker was 5. 5 more things were produced than with 2 workers. Multiply the marginal product times the price, and I get MRP for that third worker, which would be $10. Now I can keep on doing that for my 4th, 5th, 6th, 7th, 8th workers, etc., and plotting each of those MRP numbers. What I'm going to get is a line that looks like this. Now this line is MRP, but most importantly for this screencast, this line you can also see as this firm's demand for a resource. Because again, if you go back to the rule for employing resources, hire everyone whose MRP is greater than or equal to their MRC, that's essentially what this line is showing. So for example, let's say that MRC was equal to $10. Let's say that each worker costs $10. That's MRC. If I told you that and I simply asked you to look at this column and ask me which workers would be hired, well, you'd hire each worker whose MRP was greater than or equal to $10. So you'd hire the first worker, and you'd hire the second worker, you'd hire the third worker, but you wouldn't hire the fourth worker. So if the wage was $10, you would hire 3 workers. Well, look at the graph. At a price or a wage rate of $10, you wind up hiring 3 workers. What this line is showing us is the firm's demand for a resource. I could tell you any price for a worker, and this line will tell me how many workers this firm would demand. So again, if the going wage rate was, let's say, $4, you would hire 1, 2, 3, 4, 5, 6 workers. You wouldn't hire the 7th worker. Again, you can simply go to the graph. If the wage rate is $4, you would hire the 6th worker, but not the 7th. That's what the demand curve is showing me. Now notice a couple of things about this demand curve. If we're dealing with a perfectly competitive product market, MRP is dropping. You can see those numbers dropping here, 14, 12, 10, 8, 6, 4, 2. In other words, the demand curve is downward sloping. And in perfect competition, the demand for a resource is downward sloping for one reason. The reason that MRP is dropping is because marginal product is dropping. And remember that marginal product drops because of the law of diminishing marginal returns. Workers eventually get crowded, bump into each other, miscommunicate. In other words, these numbers are dropping simply because these numbers are dropping. And again, marginal product drops because of the law of diminishing marginal returns. The second thing I want you to notice about a firm that's in a perfectly competitive product market is that we can use either formula to calculate MRP. We can take marginal product times price to get MRP, or we can simply take the change in total revenue divided by the change in the number of workers to get the same result. All right, so far so good. What about imperfect competition? What if the firm isn't selling in a perfectly competitive product market? In other words, what if the firm is a monopolist or a monopolistic competitor or an oligopoly? Now, the big important difference here is that unlike in perfect competition, the price of the product isn't constant. Remember that if you're dealing in imperfect competition, if you want to sell more, you have to drop the price of your product. That's going to make our chart look a little bit different, but more importantly, that's going to make that MRP line or that demand curve look a little bit different as well. So we're going to start off with the same exact information. Hiring various amounts of workers, these numbers haven't changed. We're going to assume all of their marginal product numbers haven't changed either. We're still dealing with the law of diminishing marginal returns. Marginal product drops as we hire more workers. But the big difference between these two charts is what's going on in the product price column. Notice obviously the prices aren't all the same. If we want to sell more in imperfect competition, we have to drop the price. That's going to make the total revenue numbers look different. It's also going to make the MRP numbers look different. We can't simply multiply the marginal product times the price anymore to figure out MRP because price is constantly dropping. We have to use the second formula here, the change in total revenue divided by the change in the number of workers. So as I go from 0 workers to 1 worker, total revenue goes up by 1820. That's what the MRP is of that first worker. As I go from 1 to 2 workers, total revenue goes from 1820 to 3120. The difference there is 13. So that second worker is adding $13 to my cash register. That's the MRP of the second worker. When I plot out those MRP numbers into the graph, I can get the imperfectly competitive product market's seller's demand for a resource. Easy for me to say. And I want you to notice that this line looks a little bit steeper than it did in perfect competition. I'll try to go back and show you. Here's what it looks like in imperfect competition. And here's what it looked like in perfect competition. Notice that in perfect competition, the line is a little bit flatter, a little bit more elastic. Here it's a little bit steeper, a little bit more inelastic. Now there's a reason for that. In imperfect competition, marginal revenue product is dropping. These numbers are dropping, but now they're dropping for two reasons. They're dropping because marginal product is dropping, just like in perfect competition, but they're also dropping because the price of the product is dropping. The workers are sequentially worth less, and they're worth less at a faster rate because as you hire them, not only are they getting less effective, but the price of the product that they're producing is actually going down. So in imperfect competition, marginal revenue product drops, and it drops for two reasons. For the reason it did in perfect competition, the law of diminishing marginal returns, but now for a second reason as well, the fact that price has to drop in imperfect competition. What that means is that in imperfectly competitive product markets, MRP, or the demand for a resource, is going to be a little bit steeper, a little bit more inelastic. And again, remember that you can only use the second formula for MRP when we're dealing with this kind of product market because price is constantly changing. All right, so the upshot of all this is that in terms of the demand for resources, product markets matter. We're talking about the resource market, and that's what this unit is about. But as we just saw, the product market that the seller is operating in matters in terms of the demand for resources. In perfect competition, MRP dropped due to the law of diminishing marginal returns. And in imperfect competition, MRP drops faster, is more inelastic, due to the law of diminishing marginal returns and the fact that the imperfect competitor has to lower its price to sell a higher quantity. So now I'm going to talk about the determinants of resource demand. What is it about a certain resource that makes it be in more or less demand from the point of view of a business? What makes a resource like workers more or less in demand? Well, if you think about the formula, and again, here I'm using the formula that we can use in a perfectly competitive product market. MRP is equal to marginal product, how awesome the worker is, how much they're producing, how much they're adding to production, times the price of the product that the worker is producing. So if marginal product increases, MRP, or the demand for a worker, is going to increase. Awesome workers are going to be more in demand than not awesome workers. Alternatively, if the price of the product that the worker produces increases, the demand for that worker is also going to increase. Now this students have a little bit of trouble with, especially this first point. Some students think that if workers become more awesome, if marginal product rises, you'd actually want less of those workers. But that's kind of faulty logic. It's not a zero-sum game. Think back to product markets. Think back to the demand for candy. If I told you candy became more awesome, and I asked you what happened to the demand for candy, you would probably tell me that demand would rise. It's not like we have a quota of deliciousness that we have to fill in our mouths, and that more awesome candy would more quickly fill that quota, and that demand would go down for candy if it became more delicious. Well, the same thing is true with workers. If workers become more delicious, we want more of them. We don't want less of them. So if marginal product rises, we want workers more. If the price of the product that they produce rises, we're going to want them more. Again, you can simply apply this to the formula. If either of those two things increase, MRP is going to increase. So if you're a worker and if you want to be in high demand, you have two options. You have to either be an awesome worker, have a high marginal product, or you have to produce a product that sells for a high price. I'll give you an example. Before my stint as a teacher, I was a corporate lawyer, and we billed by the hour. So the marginal product for us was essentially how many hours we can bill. Well, there's a reason that I got paid so much as a corporate lawyer and I don't get paid so much as a teacher. In terms of being a corporate lawyer, my marginal product was pretty high. I had to bill at least 2,500. Some people billed up to 3,000 hours a year. And the price of the product that I was producing was also really high. I think that in my law firm, they were charging, for my time, I wasn't getting this money, but the law firm was, something like $400 or $500 an hour for my time. So I was worth a lot to the law firm because I was billing many hours, had a high marginal product, and the price of the product that I was producing, excuse me, just died there a little bit. The price of the product that I was producing was also really high. That's why I was getting paid so much as a lawyer. Now think about me as a teacher. Marginal product is very hard to measure as a teacher. You know, what does it mean to be more productive as a teacher? And what is the price of my product? Essentially, it's zero, right? School is free. So there's a reason I was getting paid what I was as a lawyer and why I'm getting paid what I am as a teacher. In fact, as a lawyer, my bonus for the first year was about the same amount as my entire first year salary as a teacher. Living the dream. All right. Other factors that might affect the demand for a resource would be the change in the price of a substitute resource. So let's say you're producing t-shirts and you could use either workers, for example, or machines. Well, if the price of machines goes down, that's a substitute resource, you can imagine what would happen to the demand for workers. Also, the change in the price of a complementary resource. Think like cashiers and cash registers. Those might be complementary resources, resources that are used together. Well, if the price of cash registers goes down, you as a business might want to use more cash registers, but to do that, you're also going to need more cashiers. So if the price of a complementary resource changes, that also might change the demand for some other complementary resource. Now this brings up one ethical policy issue among many that you might come across in this unit. I'll give you an example. Let's say that there's someone named Courtney who's really smart and works really hard. She grows up, she gets a great job, she makes lots of money. Let's say there's someone else named Jason who isn't that bright. He's also extremely lazy and almost never puts much work into anything. He grows up, gets a minimum wage job, and makes the minimum wage. Now this brings up something called the quote-unquote marginal productivity theory of income distribution, which essentially means that in a free market system, you get what you give. In other words, if you have a lot to offer the resource market, if you're very productive, if you're smart, if you work hard, you will theoretically get paid a lot. Your marginal product will be higher than someone who's lazy or dumb or whatever. If you don't have much to offer, if you're lazy, if you're not smart, if you don't work hard, you're not going to get paid a lot. Your MRP isn't going to be that high. You're not going to be that in demand. Remember, MRP is the demand for a resource. And MRP is equal to marginal product, how awesome you are, times the price of the product you produce. Well, I'm going to leave you to think about what really determines someone's marginal product. What really determines how awesome they are. What really determines what they have to offer the resource market. Think about Courtney. She's really smart and she works really hard. Did she really earn those things? Did she really earn being smart? Did she do something to make herself smarter? And about the working hard thing too. I've always been a really lazy person, and I wish I wasn't. It's not that functional to be a really lazy person. If I could choose to not be a lazy person, I would choose that. But I don't really feel like I have that choice. So whether you deserve what you get really depends on whether you think that you deserve what your marginal product is. And I'm hoping to have a little bit more time to talk about this in class, but I just want to leave you with these thoughts. Do people who achieve a lot, do they really earn their attributes? Again, we'll have to probably leave this to class to talk about a little bit more. All right, one final point. This idea that some people are going to wind up getting paid more than other people is going to lead to some amount of income inequality in a certain country. And the more free market system you have, the more income inequality you're likely going to see. We're going to let really productive people earn lots of money and non-productive people earn not that much money. So one way to capture this is with what's called the Lorenz curve. It's a measure of income distribution within a country. So I'm going to show you what a Lorenz curve looks like. You don't need to understand it quite as deeply as you need to understand, for example, a monopoly graph, but you're likely to see something like this on the AP exam. What the Lorenz curve shows is what percentage of the population in a country gets what percentage of the income. I'll show you what I mean. Here's a typical Lorenz curve. On the horizontal axis, I have the percentage of the population. So 0%, 1% of the population, half the population, the entire population. On the vertical axis, I have the percentage of the income that they get. 0%, 50%, 100%. Excuse me. This straight line represents perfect equality. In other words, 0% of the people getting none of the income, half the people getting half the income, all of the people getting all of the income. The Lorenz curve shows you what's actually going on in a certain country. So in this Lorenz curve, I see that something like 10% of the people are only getting like 1% of the income. When I go up to 50% of the population, I see that they're maybe getting, 10% of the income. The more the Lorenz curve deviates away from this vertical line, the more unequal income distribution is in that society. And that amount that it deviates is called the Gini coefficient. Now you don't need to know how to calculate the Gini coefficient, but you need to know what it is. So let me show you a couple different countries' Lorenz curves to show you how this works. Here's Sweden. And notice that Sweden's Lorenz curve is pretty close to this 45-degree diagonal line. In other words, Sweden has a pretty even distribution of income. On the other hand, take a look at the United States. Here's the United States' Lorenz curve. And notice that it deviates pretty strongly away from this 45-degree diagonal line. In other words, in the United States, 50% of the population only have maybe 20% of the income. You can use the Lorenz curve to see exactly how unequal or fair, if that's the word you want to use, income distribution is in a certain country. Here are some of the most evenly distributed income distributions: Sweden, Denmark, Slovenia for some reason, Iceland, Slovakia. And here's where they're the least evenly distributed. Places like Namibia, South Africa, Lesotho, Botswana, and the much prized Central African Republic. All right, gonna stop that one there. See you next time.
Honey, or let's go play.
I don't feel like it.
Why are you always in such a bad mood?
I have a nail in my anus.
Oh.